In this video, we are going to discuss about collections in Java. Let's now go into the introduction part of collection. The collection in Java is a framework that provides an architecture to store and manipulate group of objects. Java collections can achieve all the operations that you perform on a data like searching, sorting, insertion, manipulation, and deletion. Java collection means a single unit of objects. Java collection framework provides many interfaces such as set, list, queue, and double-ended queue, and many classes such as ArrayList, LinkedList, vector, priority queue, hashset, linked hashset, and treeset. Now let's look into the hierarchy of collection framework. The given diagram clearly explains the various interfaces and classes that are extended and implemented from one another. Now the collection is an interface, and this collection interface, it further extends interfaces such as list, queue, and set. And if we take for example the list interface has got 4 classes under it. That is the array list, linked list, vector, and stack. All these implement the list interface. So in this video, we are only going to discuss about the list interface. Now, if you take the list interface, it is an interface which inhibits a list type data structure in which we can store the ordered collection of objects, and a list can have duplicate values. So in a list interface, the collection of objects will be ordered and duplicate values are allowed. List interface is implemented by 4 different classes, namely ArrayList, LinkedList, vector, and stack. Now let's look into each one of this with an example. First, let's take ArrayList. ArrayList class implements the list interface. What is this ArrayList? It uses a dynamic array to store the duplicate element of different data types. The duplication is allowed. The ArrayList class maintains insertion order and is non-synchronized. So order of insertion is maintained in ArrayList and it is non-synchronized. The elements stored in the ArrayList can be randomly accessed. So if I want to access the 9th element in the ArrayList, I can access it. So random access is possible in ArrayList. Let's look at an example. Now in this example, we are going to simply create an ArrayList and we are going to add objects to this ArrayList. Now how do we create an ArrayList? What is the syntax for creating an ArrayList? This is the syntax. Give ArrayList. This is the name of the class and this is the type of object that the ArrayList is going to store. So here you remember we already discussed about generic programming. That generic programming is brought in here. This ArrayList is a generic class. Please make a note of this. So now I am creating an ArrayList called as list. And then using the add method, I am going to add objects into the ArrayList. So objects that are given here as example, Ravi, Vijay. Again, Ravi is added, Ajay is added, which means Ravi is duplicate. And ArrayList will allow duplication elements to be stored. So that is why this duplicate value is given here. And the list, I want to traverse the list. After you add objects to the list, I want to just go across the list, traverse the list. So for traversing the list, I make use of the iterator class. So iterator, I create an object and then what I do is I use the method called as hasNext. As long as the iterator has got another object, the list will be traversed one after the other by printing the values that are there in the array list. So for printing the next value, I use the next method. So this is how we make use of the array list. Please remember, whenever we use the collections, we'll have to import the util package. You have to say import java.util.start. Let's move on to the next type of class. The next one is linked list. Linked list implements the collection interface. And it uses the doubly linked list internally to store the elements. And please remember, it can store the duplicate elements. And it maintains insertion order and is not synchronized. In linked list, the manipulation is fast because no shifting is required. We already know the difference between an array and a linked list. The advantage of linked list over array is brought in here. That is, shifting operation is not required if you are going to use the linked list class. Let's look at the example. I'm going to write a very similar example like that of the array list. We are going to create an object of type linked list. So we are going to create a linked list object that is called as A1 here, and then I'm going to add the objects by using the add method. So I add the objects, and again I'm going to traverse it using the iterator. I create an object of iterator, and then using the hash next method and dot next method, I will print the elements that are available in the linked list. Let's move on to the next class, which is the vector class. The vector uses a dynamic array to store the data elements. It is similar to array list. However, it is synchronized and contains many methods that are not part of the collection framework. Now, if you look at an example for the vector class, now if you take the example, I'm creating an object of type vector, and then using the add method, I add values, and using the iterator, I create an iterator object, and using the hash next method and the next method, I will traverse through the vector and print the elements in the vector. So this is the example for vector. Now the last class, which is the stack class. Stack class is nothing but it is a subclass of the vector class. So it's a child class of the vector class. It behaves very similar to the stack data structure. The stack data structure is based on the concept of last in, first out. Whichever went in last will come out first. So the same concept is implemented here. The stack contains all of the methods of the vector class, and also it provides its own methods like push and then peek and pushing an object, pop. So all this is done in the stack class. Let's look at an example. Now in this example, I'm creating an object of the stack class and I push certain objects. So when I say pop, when I say stack.pop, see I'm pushing so many objects. I am pushing Ayush, Garvit, Amit, Ashish, Garima, and then I say stack.pop. So which is the last one which went in? The last object which went in is Garima. So when I say stack.pop, Garima will be popped off. So this is how the list interface is implemented by the 4 different classes. Thank you.